The most complicated skill is to be simple, said the essayist Dejan Stojanovic. And this is most evident in how we compute calculus functions. We now know that the idea of calculus is such powerful and extensively applied because limit and continuity make it simple. And at the computational level, being competent in calculus is almost all about algebraic and trigonometric competencies. Thus, the key computational skill for calculus expressions is practice, just the way it is for mastering algebra and trigonometry. It is no oversimplification to state that curricular calculus is about knowing algebraic and trigonometric identities and the ability to simplify expressions, and several basic formulae. We will explore the facets of this through examples of calculus expressions. There is no solution or computations offered in this lesson. The examples should reinforce how computations in school-level calculus need practice, memory, and more practice. And in that case, calculus is a dependable scorer. In fact, the key idea of this lesson, the last one on calculus, is to put in perspective the perceived understanding of the key to success in scholastic calculus. Practice, practice, and practice. It is such. Conceptual and computational calculus at the school curricular level are not really overlapping or reinforcing enough. The concept of calculus, that is the of idea, limit, continuity, differentiation, integration, and differential equations, is no real help in scoring in school-leaving exams and competitive exams too. The decades of all those entering the portals of engineering colleges and mathematics departments in universities bear eminent evidences of mastered computational calculus. Methods matter in school calculus. Get them right. These are popular rules in calculus computing. The point of showcasing them here is that these are the simplest arithmetical expressions too. The simplest of arithmetical logic and the better of the calculus rules are such similar. An example of simplification of calculus expressions. It is as basic algebra as it gets. This is a favorite class of example for me when showcasing the method rigor of calculus. Even in matrix expressions, we just follow the simplest logic. The derivative of constant terms is zero, even if it is in a matrix. This list of 4 algebraic and trigonometric formulae is only to show how the memorization is so important for solving calculus questions. And there are many of these. This is a simple example of how the question cannot be solved without the knowledge or the recall of the trigonometric function. Tan of pi plus x is tan x. Here is an example of practice simplification skills, where the simplification step is apparently a more complex expression and needs the knowledge of a specific trigonometric identity. And of course, the confidence of knowing the path to solution with high confidence. An example of algebraic simplification of an integration expression. This is quite what calculus is about. This is an example of practice to gain an eye for simplification. The solution of the question is quite dependent on simplifying the question to get the expression limit of sine ax by ax in the question. This is an example of applying standard algebraic and trigonometric simplification in calculus. And a tough problem in calculus is mostly about just more of these in the same problem. This is another simple example of how a few identities and functions come together to solve a calculus expression. This is integration by substitution to simplify solution steps. and it must remind you of the substitutions in algebraic expressions. Hopefully, it may be appreciable now why and how pre-calculus courses and preps are centered around algebra and trigonometry. And thank God for it, all of that has made calculus highly accessible to scientists, technologists, engineers. In that process, made invention and innovation easier. Identities, formulae, or rules, and eye for simplification of expressions cannot really be memorized. It takes hard and long road of practice to develop reflexes around steps in solutions. It is also hoped that the practice would be in peace and appreciation of its place in mastering calculus, and in knowing why conceptual mastery of calculus is very important and kind of separate from calculus expertise for exams. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.